numericals continuously for an hour, maths problems. And after an hour, you will say, "Ma'am, I'm very tired. I will not work more now. I need a break." But actually, your teacher will say in physics, "You're not doing any work." You will get surprised and you will say, "Ma'am, how can you say that? I'm working, I'm tired." But that is all mental work. Mentally, you might get tired, you feel lethargic, you need a break. But physical work, which we discuss in physics, is totally different from the mental work which we do in day-to-day life. So what we are going to do today is, we are going to discuss class 9th topic, work and energy. We will be trying to understand today what is work energy and power. We will be trying to calculate kinetic energy and potential energy. We'll be discussing about conservation and transformation of energy, and in the end we'll discuss about power. So let us quickly visit what is work. Work is done whenever an application of force and object gets displaced. This box is kept on the table. You apply a force, it gets displaced through the distance d. So how will we calculate it? We will find it out using the formula. Work is the product of F into F with the displacement, force with the displacement. So unit of force is Newton and unit of displacement is meters. So the unit of work is joules. Now when we consider work, we do classify work being positive, negative and zero. Now how does it make sense? Let us find out. So if an object is falling down, you have dropped a ball down from a height. Now when the ball is coming down from a height, the force and displacement both are in same direction. So as they both are in same direction, the work done is said to be positive. So whenever the force and displacement are in same. Now you can think of any number of examples. You are rolling a ball, you are kicking a football, you are playing cricket and you hit, the batsman hits the ball. In all these cases, the force and displacement are in same direction, and when it is in same direction, it is positive work. Now, negative work. Negative work happens when force and displacement are in opposite direction. Force is going one side and displacement is on the other side. For example, when you swim freestyle, you push the water backward, but your body is actually moving ahead. So when your body is actually moving ahead, the work done is the product of force and displacement, but since they are in opposite direction, it will be negative. Another example of it is when you walk, when you row a boat. In all these cases, the work done will be negative. Next is zero work done. Now, zero work done happens when you apply force on an object and the object does not get displaced. It remains at its place. So, if the object remains at its place, the displacement is zero, work done is zero. Another example can be, I am asking the notebook which is lying in front of you, get up and move and go to X student. So, the notebook itself can't move until unless we apply a force, the object will not move. So, if the force is zero, work done will be again zero. Another example can be that force and displacement are at an angle of 90 degree, perpendicular to one another. Now, why does it happen? It happens because the force does not have a component in the direction of displacement. Let us discuss here. Work done is Fs. Now, the object, if you look in the lower figure 2, you will notice that in this case, what is happening? The force is at an angle of theta to the displacement. So, the formula for work done will be Fs cos theta. Now, if this theta becomes 90 degree, we know cos 90 is 0. So, the work done will become 0. So, we have discussed work which can be positive, negative or 0. Now, let us discuss next energy. Now, what is energy? Energy is the capacity to do work. The more work you will do, more there will be energy. Now, energy is measured in the unit of joule. Since doing work will give you energy, and when you do work, you will actually spend energy also. So, we will be discussing in this chapter two major kinds of energies, kinetic energy and potential energy. Kinetic energy is the energy by virtue of motion of an object. It is measured by the formula half mv square. Now how do we find it out? Let us consider work done on an object is force into displacement. Now here, when we consider W is equal to F into S, you know the third equation of motion. V square minus U square equal to 2AS. So what is S? S is V square minus U square divided by 2A. So we will substitute that in the force formula F equal to MA. When you will substitute it into force formula, you will get work done MA into V square minus U square upon 2A. AA cancels, so it becomes half mv square. You are considering here the initial velocity to be 0. If it is not 0, then the formula will be half mv square minus u square. Is that clear? Next is potential energy. Now potential energy, you all have the potential to do a lot of work. So potential energy means the energy possessed by an object due to its position or state. Now the cat of that lady has climbed up on the tree. It has gone up to a height h. So work done is F into S. Now what will be force? Mass into the acceleration due to gravity, acceleration. So force is mg and the displacement is h. So potential energy will be equal to work done mgh. Next is transformation of energy. Now whenever an object moves, energy gets transformed or changed from one form to another. Like in example, in gadgets, you are using a fan. So electrical energy gets transformed to kinetic energy. In bulb also, electrical energy is transferred to heat and light energy. While riding a bicycle, chemical energy gets transformed to muscular and then the kinetic energy. In nature also you observe transformation, change of energy. Like in photosynthesis, sunlight is getting transformed to the chemical energy of food. During rain, the potential energy of water stored in the clouds gets converted to the kinetic energy of falling water. Now, why the energy gets transformed? The energy gets transformed because of law of conservation of energy. Now, law of conservation of energy states that energy can neither be created nor destroyed. It can only be converted from one form to other. It always remains constant. Next is like you are firing a cannon, then energy gets transformed. When you have a pendulum is oscillating. So at the center position it has only kinetic energy. At extreme positions it has only potential energy. And at any intermediate position it will have both potential and kinetic energy. Another example is a falling object. When a ball is falling from a height, at the highest point it is having only potential energy. At any intermediate position it will be sum of potential and kinetic. And the movement just before hitting the ground it will have only kinetic energy. So a car coming down a slope also, its energy gets transformed into kinetic energy. Next is, or the last is power. Now what is power? Power is defined as ability to do work. If you want to compare work done by any two machines, any two people, you will need a parameter, and that parameter is power. Power is work done upon time. Now work done is force into displacement. So force into displacement upon time is velocity. So you can even write power as force into velocity. Unit of power is joule upon second, that is watt. So what we have discussed in this chapter, we have discussed about what is work, what is kinetic energy, what is potential energy and what is power. Happy learning. Have a good day.